So, have you ever wondered how companies like Netflix or Amazon process just these mind boggling amounts of data? Well, the answer very often involves a powerful tool called Apache Spark. Today, we're going to break down exactly how it works, and we'll use a simple analogy that you'll find in pretty much any kitchen. First things first, let's frame the problem. Your laptop, it's great for spreadsheets, watching movies, you know the drill. But what happens when your spreadsheet doesn't have 1,000 rows, but 1 billion? Or 1 trillion? A single machine just doesn't have the power or the memory for that. It would take forever if it could even finish at all. So how do you solve a problem that's just too big for one? Well, the answer is you don't use just one. You build a team. Instead of one super powerful computer, you use a whole group of them, and we call that a cluster. And the tool that acts as the brilliant manager for this team, the one that coordinates all their work so they function as a single unit, yep, that's Apache Spark. To make this crystal clear, let's use an analogy. Imagine you have to cook an absolutely incredible feast. Not for 10 people, but for 10,000. Your home kitchen, it's just not going to cut it. Think of it this way. Your personal computer is like that home kitchen. It's perfect for everyday meals. But for that massive feast, you need an industrial-sized kitchen. And that is exactly what a computer cluster is. It pools all the resources of many different machines to handle a gigantic job. And Spark? Spark is the framework that manages that entire operation. Okay, so if Spark is managing this giant kitchen, who's on the crew? Let's meet the key players that Spark assembles to get all that data processed. Every great kitchen has a head chef, right? In Spark, we call that the driver. The driver is a dedicated process, think of it as a program, that acts as the absolute heart of the operation. It runs your main code and is responsible for the entire workflow, from the very beginning to the very end. So the driver essentially has three main jobs. First, it maintains all the critical information about the task at hand. Second, it takes your instructions, which is kind of like the recipe for your data analysis. And third, it analyzes that recipe, breaks it down into all these individual tasks, and then schedules who does what and when. It truly is the master planner. Now, the head chef can't do all the chopping, sautéing, and cleaning alone. They need a kitchen staff. And in Spark, these are the executors. They are the worker processes that are running on all the different machines in the cluster, just waiting to take their orders. Executors have two simple but absolutely vital jobs. Do the work the driver assigns them, and then report back on their progress and results. That's pretty much it. They execute the plan, piece by piece, all in parallel across the entire cluster. All right, now let's get to Spark's most powerful concept. It might sound a little strange, but Spark's incredible efficiency actually comes from a principle we can call strategic laziness. Before we get to that whole laziness part, we need to understand what we're working with. The main way Spark organizes data is called a data frame. Just think of it as a giant spreadsheet. But instead of living on one computer, its rows and columns are distributed across all the machines in your cluster. All your ingredients are perfectly organized. This brings us to the Spark recipe, which happens in 3 phases. First, you define your transformations. These are just the steps you want to perform, like filter out bad data or sort by date. Now, crucially, nothing actually happens yet. No cooking has started. Second, this is where lazy evaluation comes in. The driver, our head chef, reads your entire list of transformations and creates the single most efficient plan to get it all done. And finally, only when you call an action, like shouting serve and asking for a final result, only then does the entire kitchen spring into motion to execute that perfectly optimized plan. This quote from the source material really sums it up perfectly. By waiting, Spark can look at the entire data flow from end to end and make these incredible optimizations. For example, if your final step only needs one single row of data, Spark is smart enough to figure that out and only fetch that one row from the very beginning. So instead of reading a terabyte of data, it reads a few kilobytes. I mean, that's the difference between waiting for hours and getting your answer in milliseconds. It's a real game changer. So, what can this amazing data kitchen actually make? Well, it's not just for one type of data processing. Spark is a full-service culinary toolkit. With something called structured streaming, you can analyze data as it's coming in. Think of it like a kitchen that can serve a constantly updating, real-time tasting menu. This is perfect for things like live fraud detection or monitoring social media trends as they happen. Spark also has a really powerful built-in library, MOlib, for doing machine learning on massive data sets. This is like moving beyond standard recipes and into molecular gastronomy. It allows you to build complex recommendation engines or predictive models at a scale that was pretty much unimaginable before. And for understanding really complex networks, Spark has tools for graph analytics. This is like mapping out all the intricate relationships in a social network or optimizing a global supply chain to find the most efficient delivery routes. Okay, so after all that, what are the key things you should really take away from this explainer about Apache Spark? Here are the three crucial points. First, Spark is the ultimate manager for big data, coordinating a team of machines to do what one simply cannot. Second, its superpower is lazy evaluation, planning the entire job before starting, which makes it incredibly efficient. And third, it's a versatile Swiss Army knife, handling everything from real-time streams to heavy-duty machine learning. And that brings us to the end. Tools like Spark are fundamentally changing what's possible by removing the limits on data size. And it leaves us with a final, fascinating question. With that kind of power, what problems would you want to solve? Thanks for tuning in.